Good afternoon, everyone, and welcome to today's webinar organized by the Future Classroom Lab titled A Journey into the Elegance of Atoms. My name is Konstantinos Andronikidis. I work for European Schoolnet, and I have the pleasure to be your host today. Before we start introducing our speaker, and for those that do not know us, European Schoolnet is a network of 34 ministries of education, and our goal is to support education stakeholders in Europe and beyond in the transformation of educational processes. The Future Classroom Lab is an initiative of European Schoolnet and is an inspirational learning environment in Brussels that challenges visitors to rethink the role of pedagogy, technology, and design in their classrooms. Today's webinar is organized in collaboration with Shape Robotics, a company that specializes in tailor-made STEAM lab solutions designed to integrate science, technology, engineering, arts, and mathematics to provide a holistic, interdisciplinary approach to learning. Shape Robotics is one of the Future Classroom Lab industry partners, and we are happy to be joined today by Christian Lacraru, a teacher and expert who will guide us through today's lesson. The webinar will demonstrate an innovative way in which technology is used to teach science, in this case, presenting the structure and the function of an atom. The event will show in practice how STEAM technologies can be used to make clearer to students the interconnectedness of mathematics, chemistry, and physics in the structure and functioning of atoms. You, as the participants, will have the opportunity to explore a pedagogical approach which incorporates a variety of technology products to structuring and delivering a chemistry lesson after the presentation. We will have some time to address any comments, questions you might have. So feel free to share your thoughts, any questions in the Q&A sections that you can find under the platform that you are watching us, either YouTube, Facebook, or Twitter. So now I'm gonna introduce, I'm gonna bring in our speaker for today, connecting from their lab. Hi, Christian, can you hear us?
Yes, of course. Hi, Konstantinos, and thank you for your great words and for your perfect introduction. Yes, I'm Christian, and I'm the Education Director at Shape Robotics, and I'm delighted to welcome you in this STEAM lab, this incredible lab, where we have a lot of technology because we believe in ecosystems and integration technology. So we have so much technology that we are able to develop content for any kind of schools. It doesn't matter if you have, for example, if you are an agricultural high school or if you are a technical high school. I invite you to scan our QR code in order to visit our lab, because you will be able to travel inside the lab and to learn about our equipment here. We have a lot of equipment, and I will talk more about each of them in the next minutes. I promise that at the end you will have the PowerPoint with the QR code included, of course, and I invite you again to visit us in 360 degrees. In this lab, we have so much technology, as I said, that we are able to develop any content. Our star is the Fable robot, of course, because we can do anything with this modular robot. But we have, in other words, we have 3D printers, and we are using 3D printers a lot in our projects. We have the 3D pen, because if you are good at art, why not to help us to develop the content with the 3D pen? And we have the VR headset. We are using VR, but not only the VR, we are using AR at the same time. And I will show you later how we can do this. Now, I want to invite you into an incredible journey into the elegance of atoms. Our objective is to understand the atomic structure and properties of atoms through STEAM approach, because that's what we are doing here, STEAM approach. And in this lesson, as I promised, we will use educational tools such as 3D printers, 3D pencils, VR glasses, and of course, robots. Let's move on. So the first question is, what does an atom look like? And for this, I will go back to our to our board, and I will try to draw an atom. This is the nucleus, and this is an electron, and the electron orbit around the nucleus. Remember that an atom is the basic building block of all matter and chemistry. Everything is made by atoms. You are made by atoms. I am made by atoms, and everything here is made by atoms. This is great, right? So let's move on and find new things about these atoms. So what is an atom made of? An atom is made of nucleus, as we talk, and an electron. This is the best way to clean your table. So inside the nucleus, we have something more, and we will talk about this because the nucleus is not only the nucleus. Inside, we have protons and neutrons. But let's come back to the electron. And the electron, I told you, they travel at a high speed around the nucleus. High speed means about 2,200 kilometers per second. That means in about 18 seconds, the electron just goes around the entire Earth. Incredible, right? Let's move on. Now, inside the nucleus, as I told you, we have protons and neutrons. Electrons has negative charge, and the protons has positive charge. And now I will tell you something that we have to remember because we will use it later in our homework. Inside the nucleus, we have the protons, as I said. The number of protons that we have inside determine the atomic number of the element. So, for example, if we have hydrogen with 1 protons, that means the atomic number of hydrogen is 1. And for helium, because we have 2 protons, the atomic number is 2. It's pretty simple. And please remember this. Now I want to invite you to see another way the atom. Coming back to this slide because I will use a VR headset. And I'm using a Class VR software. And I'm able to put my glass on. And now I can see this model in AR. And I'm using AR because in this way I can see other colleagues. And me as a teacher, I can control the entire class. I can even show them where to take a look. Let me just take a pen. For example, now I ask them to look in this direction. So I can control and I can see where everybody is looking on my, my model. Now, if I'm using this cube, I'm putting my glass again, I can see the model, and now I'm looking at the cube, I'm rotating it, and the model stick on the cube. And now I'm able to rotate the cube, but actually I'm rotating the model. It's pretty nice. You know, it feels like I can take the cube and put it in my pocket. Okay. Now, because we know how an atom looks inside, we can use other tools to see better how it works. And I will move to another slide. And now is the moment when everybody in the class goes to work, because we can use smart tools in order to achieve smart results. So if we want to use it, as I told you, the 3D pen, which is working with 3D filaments similar with the 3D printer. And it's very easy to develop new models. And now, if we are good at art, as my colleagues are, we can develop this kind of model, which actually is an atom with a nucleus and 2 electrons with 2 orbits. But of course, you can develop any model you want if you're taking a look at the periodic table, for example. And I prepare something fun because I can connect this robot with a motor to my model. And when you present in the class, you can make the model spin. And I'm programming it in Fable Blockly. I will show you immediately how it works. Well, it's fun, because it's fun to represent it in this way. It's fun to be able to show to everybody from all the points. Actually, it looks like an AR, because in AR with the cube, we did the same thing. But now we can understand better what is inside using the 3D pen. And if we want to understand more and to be sure that we understand correctly, we can use another tool. We can use the 3D printer. And now I'm going to the 3D printer that we are using. It is an educational one. And when I'm saying it's an educational one, is that because it is very safe to use it. I cannot open it. I can open it just when the temperature inside it's lower enough and it's safe for the kids to take the model from there. Even here up, we have a dome, the plexiglass dome, that protects the kids to put the hand inside. So we are safe to use our 3D printer. Now, I will take off a model. It's ready now. It is the hydrogen model. And of course, you can, you can design in other ways, but important is to be correct if we are talking about atoms and electrons that orbit around it. This is a hydrogen one, and this is an oxygen one. And yes, it is directly 3D printed and able to do this, which is absolutely fantastic. And I will give you an idea. You can use this kind of models for homeworks, because it's better to go home with this model, and it's better to, it's faster to remember what we discussed in the classroom when you have the model and you can take a look in the evening before go to bed, and then in the morning to remember the structure. And it's easier to reproduce it in the classroom. So why not to use a 3D printer as a homework device? I will close it. And now I will show you how we are using the robots in order to evaluate what we have done. For this, I'm using a Fable Blockly. It is a program that works in blocks, but it works even in Python. So if you have smaller kids, you can use Blockly program, which is better to understand and easy to interact with, because you can read the command and it's very simple to understand the results. But if you are going to a higher school, you can use Python and you can directly program the robots. When I mean directly program the robots, for example, here I have 1 robot, 2, 3, 4. So we have 4 robots, and we can program all of them from one program, because all of them are connected to this hub. Because this hub is green, everything should be green. Of course, if you want another color, you can choose another color. You have 6 colors to choose, but important is to have the same color with the hub to be sure that you are connected to this laptop. Because if other laptop has orange, for example, you are connected to that one. Now I programmed this tiny face to evaluate us about the number of protons. I mean the atomic number of the elements. Let's see how it works. I will connect the face. This is my hub, C33. Connect. And now I will be connected with the tablet too, and I'm able to to take a lot of sensors data from the tablet or from the phone and use it inside my program. Now I'm connected. I have everything green, so I am able to turn on the program. Okay. Now, let's see how we can evaluate our lesson.
Hello. If an atom has 2 protons, can you identify which element it is?
What do you think? Can you identify what element it is? Maybe it's hydrogen, maybe it's helium. You remember my previous slide? There was helium and hydrogen with the atomic number on it. Now, we don't have the atomic number because that's the question, and that's the evaluating moment. Let's try the hydrogen.
Take another look at the periodic table. The atomic number is exactly the number of protons.
That means I'm not right. So let's go to periodic table. And remember, we use hydrogen, which is the first one in the periodic table. Oops. And the atomic number is 1. And here we have helium with the atomic number 2. Now we know the answer. Let's go back to our robot and try our luck.
Great. The atom has 2 protons, so the atomic number is 2. From the periodic table, we identify helium. Congratulations.
Thank you. It was a good evaluation, and we can develop, of course, many other ideas, because this is the place where we can make mistakes, where we can develop debates, where we can develop ideas. We can create anything that comes in our head, because we have a lot of technology, and this technology helps us to better understand and better integrate the problems with the solutions that will be available in the real world. Now, I prepare a lot of time for the questions, and I invite you to put some questions about our lesson, about our robot, about our equipment, about our entire lab. And of course, I am glad to invite you here anytime you are able to come here in Romania, in Bucharest, visit our lab, because we are always open. This is the National Teacher Training Center, and it's open for teachers and students all the time. Thank you. So, I'm waiting for the first question.
Thank you very much for this very nice demonstration. And before we go to questions, since we also have some delay of time, perhaps you could, I don't know if you are able to show us the code that you use for this robot, or to explain to our participants what are the steps that you used to program the robot in that case.
Of course. Thank you, Konstantinos. Of course, we can show the code that we used. Just a moment. So, as I told you, we are using Blockly. Blockly is a program system that can work with blocks. That means, as I told you, I have the command written and I understand the results. So it's not necessary to code, actually. For example, if I'm using this block, move to angle 0 and 0 degrees means that, and because it's magnetically, it's very easy to show you how it works. That means my servo motors, they will be oriented with 0 and 0. That means vertical. Of course, if I'm changing the angle, they will move to that angle. So I'm able to move the sensor motors marked X or the sensor motors marked Y. And I've told you that you can do this in Python. This is the code in Python. So it's very easy. Just one click and you will be able to work directly in Python. But if it's too early for you to do this, you can continue in Blockly And in the same time, on the right side of your screen, you have the Python code. So it's very easy to put a command and see the results in Python in real time. So it's very easy to program this kind of robot. So this is my program. For example, if I'm pressing a key, let's see the detection. If I'm checking for color red, which means in my demonstration, the hydrogen, the robot will make some movements. It will be sad. That's why we have the tablet there, and it helps us. And at the same time, it can read a text. But not only read a text, you can record, for example, an entire text, or maybe a melody, a song. It doesn't matter, of an MP3. And the robot is able, in this system with the tablet, to play that sound. So this is a very easy way to, I don't know, to transform, for example, your robot into a guide, using in the museum. When you are in front of a painting, you can detect a color, and then the robot can guide you and can talk to you about that painting or that painter. So you can use it in any other situation. It doesn't matter if you are on a history lesson or in a, I don't know, sport lesson. Why not? Because you can go in VR to visit Bernabeu, for example, and to be able to go there where it's hard to go in other way. So you can use VR, but you can use, for example, the robots to detect the line for the field. So you can learn at in any class about new things, and you can create new ideas about what you can do there. So coming back to the code, I will code one now for you to see how simple it is. I will make a new project. It's completely empty now. And I will take a look at this, please. I'm taking this off. Okay. I will take the wheel and I will use it as a stand. I've told you that you can choose another color. I don't know, blue, it's okay? Let's be blue now. My robot has a code, 14F8. Now, I want to move, for example, 14F8, which is my module. I want to do this. And this means that I want on servo motor X going into minus direction. And I will press play. So that's all. That's simple. And this is great because you can save time thinking of your project, thinking to extend your project, your futures, your kind of use. Because you can, for example, develop a program that detects something and transmits to another robot a message, things that you can use, for example, in for a police station or for a firefighter. So it's easy to program. That means you can do things fast. In the same time, it's easy to develop a new model. And you saw that in a few seconds, we passed from the humanoid one to this model, which can be, for example, I can attach here a flashlight. And I can use it like a flashlight. I can detect in the same time with other robot another light, and I can put them to communicate, to detect and to orient this flashlight in that direction. So you can do a lot of things. I hope I answer to your question, but please, if you want to know more about our equipment, tell me. We have a lot of time, and that's why we have a lot of time to discuss more and to discover our equipment.
Indeed, thanks a lot for this information. We have a question from one of our participants who asks, well, it's more of a statement. He mentions about teacher professional development, and I just wanted to ask, what do you do in order to prepare the teachers to use this kind of technology, the robots specifically, but also the VR sets, for example, in the classroom? Because I can imagine it must be quite overwhelming for some teachers to introduce this kind of technology that is, well, sometimes it looks more complex than it is. But what is your approach to, and maybe you have some offering online, some videos or some professional development material, lesson plans that teachers can learn more and get started with the technology?
Okay, thank you for the question. Yes, it's a very good question and very important question in the same time, because we have so, I think that because we have so much technology, it is easier in the same time for the teacher to work with, because when you came into this kind of lab, you have everything working perfectly. Everything is correlated, everything is already tested, everything is already installed, so everything is functional. And as a teacher, you don't spend time to test the compatibility, for example, which is not okay in a classroom, to spend time for this and to have kids looking at you when you are trying to connect the projector with the computer. In the same time, we have video for all the equipments in this lab. So any teacher can take a look at our website, and I will show you a QR code. So we have the school flicks, we have a QR code, and thank you for this question, because I will introduce this QR code in the presentation after this, that it will be sent it to you. We have this QR code, and as a teacher, you can go directly to our website, and there you can find videos for everything from here. If you want to know how to start the 3D printer, how to feed the 3D printer, how to work with VR glasses, for example, you have videos there translated in English, so available for everybody in any moment. In the same time, we develop a manual. We develop an entire manual with 36 lessons. 36 lessons already done for any kind of class. So there you have 36 ideas of how to use equipment, giving you in the same time for you to develop your creations. Because at the first, of course, you have to understand the technology. And when you have a lesson ready, you can test the technology, and you can present the technology to other teachers, colleagues, and of course, use the technology at your class. And after this, you have to create your own ideas, because each teacher comes with own ideas, with incredible ideas. And of course, we recommend you to ask students all the time, because in the same time, they come with many ideas. Some of them maybe sound strange at the beginning, but think more that you can find a useful model for that idea. So you have video for everything in here, for any equipment, and in the same time, you have a manual with 36 lessons.
Thanks a lot for this. And another question is about exactly this, the preparation of the lessons. And you mentioned that you have examples for the teachers, but when you are developing a lesson, or when you expect the teacher to develop a lesson, what is usually the process that you go through? What are the things that you believe a teacher should take into consideration when thinking of introducing a specific technology into their lesson? For example, introducing atoms into their class, and how to evaluate what type of technology is best suited for particular age groups of students, or also different disciplines, science education, but it could also be, for example, language learning, etc. So how would you suggest, what are the tips that you would give to teachers when they are creating their lessons?
Okay, thank you. Coming back to those 36 lessons, each lesson has activities with the exactly amount of time that we recommend to understand better how much time you will spend with one or other activities. But on the same time, when you are a teacher, you have your own curriculum that you develop. What I suggest is to go inside our libraries and look for models. For example, the atom models that you saw at the beginning. It is in our library, in the classroom library, and you can take already ready models. In this way, you save time, but in this way, you use technology. In your lesson, it will be, different, because it will be colored, it will be funny, it will be correct, it will be, I don't know, well, you will see this from your students, because the lesson will be somehow different in a good way. So start from your model of curriculum, and try to take models for what already exists in the databases that we provide into this laboratory. And then you will be able to develop your content. For example, if you are travel in vacation and you are going, to visit something interesting. For example, you visit the, Pantheon. Take one camera with you, 360 camera with you. Visit the monument, and then come home and upload your video on YouTube, and then put it on your glass in the VR glasses in the class. So everybody will be able in the class to see what you already saw. And it will be very easy for you to talk with your students about why you were there and why you decide to film such a content. And it's better than coming home and said, wow, if I had a camera and if I had the solution, the technical solution to do this, well, now it's available, because we are not talking about technology of the future. Everything what you see here is technology of the present. It's here, it's with me, with us, and for everybody.
Thanks a lot for this. And we have one last question that relates more to the VR technology, and perhaps to explain a bit how you introduce the model into the VR headsets. How can a teacher perhaps download different models? Is there a space to do that with a specific technology, of course, that you're using there? But and where would you kind of suggest teachers to use VR? Of course, chemistry is one excellent example, but do you have any other suggestions around that?
Well, it's not only chemistry. As I told you before, it's even sport. Why not to visit a great stadium? It's about history, of course. It's about any class. And the good part is that if you don't have a content, you can take the content from the database. If you want to have a content, for example, if you have this mouse and you want to have it in 3D because you want to talk about this, I don't know, maybe about the design, maybe about the characteristic, the components, it doesn't matter. You can scan, 3D scan. We have a scanner in our lab. You can 3D scan. I will show you the scanner. So you can 3D scan the model, and then the model can be imported into the VR glasses library. And it can be your personal library. That means just you have the access, or it can be a shared library, which is better, because in this way you have more content from other teachers, and other teachers can access your content. If you have a content that you want to be public, you can ask to be public, and the class VR approved, an educational team approved this content and make it public after this. That's because this kind of VR glasses are only educational one. You can do anything else with them. It's just for education. So it's very easy to answer to your question to use models that already exist, but it's easier to create your model and to upload into your VR glasses. And more than this, you can upload content. And if you know that you have a student which is at home, and they can use it at home with the uploaded content inside. So you can have a hybrid class, and you can use the VR glasses in the same time. And when we are talking about about hybrid class, think about how well you can hear us now and how you can see us, because the technology that we have here for the audio video is a fantastic one. The microphones detect me, remove other sounds, and in this way I can have a class, a hybrid one, or maybe just online one without any interruptions or problems on the transmission. And more than this, of course, that with a good technology, you can invite, for example, a professor from another country to be part of your class, and which is not easy in other way, you know. And in this situation, it's very simple with just a few clicks.
Indeed. Thanks a lot for this. I don't think we have other questions. I don't know if you would like to say something before we close from your side.
Okay, I want to thank you again for this opportunity to present our lab, and in the same time to remember you to visit our lab in 360. And in the same time, if you ever comes in Bucharest, Romania, come to us, visit us, because we have technology for teachers, for school, for students, technology that it can integrate everybody. Thank you.
Thanks a lot. Thanks a lot, Christian, and thanks a lot to the whole team there at your lab for today's support. And I would like also to thank you all, the participants, for joining today's webinar. And we hope that you had the chance to learn more about the possibilities that exist to integrate different types of technologies in your lessons and to make your teaching more innovative and engaging for the students. The webinar recording will be available freely on our YouTube channel a few minutes after we finish with the live. And you can feel free to rewatch it, share it with others, and follow us on our social media, on our website for more opportunities. We have a whole series of webinars that we are organizing this autumn with different FCL Future Classroom Lab partners. So we're really looking forward to seeing you next time. So have a nice afternoon or evening or morning, and see you all next time. Bye-bye.